Alright, sixth graders, welcome back. Today we're going to be looking at numbers and patterns. By the end of this lesson, you'll be able to identify and extend patterns that you see. So first thing we're going to do is just identify a possible pattern. So being able to describe it and then use it to identify the next three numbers. So here, we want to look at what's happening to get from our first number to our second number to our third number. So from 3 to 12, we could either say that we are adding 9, but then if we tried that again, that would not work. Or we could say that we're multiplying by 4, in which case that would work from 12 to 48. So our pattern would be to multiply by 4. So then if we're looking for our next three numbers, we would just take our current number, which is 48, and multiply that times 4, which would be 192. Multiply that by 4, which would be 768, and then multiply that by 4, and we would get 3072. So why don't you go ahead and pause the video and try that for the next two examples. So from 7 to 12, we're adding 5, and from 12 to 17, we're also adding 5. So our pattern would be to add 5. So if we do 17 plus 5, our next number would be 22. Plus 5 would be 27. And plus 5 again would be 32. Our next one's a little bit different because instead of increasing, it's decreasing. We see it's going down 3. So here we would say our pattern is to subtract 3. So 14 minus 3 would be 11, then 8, and then 5. So what is a pattern? A pattern is either a design or numbers that is repeated. When we're talking about patterns, we sometimes talk about terms, which is an element or number in a sequence. And a sequence is just a numeric pattern. So how would you describe the following patterns, and can you find the next three terms? So here we're looking at sequences, and we see each one is going up by 2. So we could say that it's increasing by 2, or you're adding 2. Okay. So then we'd have 10, 12, 14. Now the next one's a little bit different. Why don't you pause the video and see if you can figure it out. So from 1 to 1 we don't see a pattern, but then from 1 to 2 we're adding 1. 2 to 3 we add 1 again. 3 to 5 we're up by 2. 5 to 8 we're up by 3. Well, if we start to look beyond that pattern, you might notice that if we get 1 plus 1, we arrive at 2. 1 plus 2, we get 3. 2 plus 3, we get 5. 3 plus 5, we get 8. So we could say that you add the previous two terms to get the next term. And this is something called the Fibonacci sequence. It's actually a really common sequence in math. So if we're looking for our next two terms, or next three terms, first one we'd have to take 5 plus 8, which would be 13. And then it's going to be 13 plus 8, because we add the previous two, which would be 21. And then 21 plus 13 would be 34. Patterns can also be geometric, meaning that we can use shapes and stuff instead of numbers. So identify the pattern and then the next three terms. So So here we see circle, triangle, square, circle. So we're going to assume that the pattern is circle, triangle, square, because based on the information we have, that would be our pattern. So our next three terms would be triangle, square, and then circle again. And we can also use tables to describe patterns. We want to make a table to show the number of dots in each figure and then tell how many dots would be in the sixth figure. So in figure 1, there's 1. In figure 2, there's 3. In figure 3, we have 6. And in figure 4, we have 10. So this would be the figure number, and this would be the dots. So if we look among the dots, we might see that it goes up from the previous one by the row that it's in, so it's always increasing. So if we want to look for the sixth figure, for the fifth figure we would add 5. So we would say that 5 would have 15, and then 6 would be adding 6 to the 15, or 21 dots.